Recording in progress. Thank you. Okay. So we've got that. And then how do we use Desmos to solve this? Somebody on Zoom, help us out. We can all hear you. Unmute yourself. Tell us. Anybody? Any Zoom people?
Just type it into Desmos, find all three of the x-intercepts and add them together.
Wait, for number 5?
For number 5, yeah, you type in the problem to the.
Does number 5 talk about x-intercepts?
Oh, Ella, we're talking.
Well, it talks about zeros.
Oh. First review. First review, not the second one.
Oh.
Sorry. First review. First review, not the second one. You have a typo somewhere. Oh, 3x plus 2, not 3x minus 2. Yeah. Okay. So if we look at number 5, now I did this one on the notes with the sub, and I actually, as I was grading this unit, some people got it wrong, which told me that some people did not watch the video the day that the sub was here. Hello, Hannah. You're good. So did anyone pay attention to the video the day the sub was here and pick up on how to do this problem? It uses some guess and check, but you do have to set up Desmos first. Yes. Yeah, you make the sliders. So what we're going to do is we did the left side of the equation first, and now we're going to type in the right side of the equation. So ax squared plus bx plus c, I'm ignoring it for right. Oh, it didn't type up the sliders yet. 3x plus 2, 5x minus 6. Okay, and then when it asks us about adding a slider, we're going to add all of them. And Keld, I love that your video is showing, but I want your face to be in there. Haha, there's Keld.
I'm back. Sorry,
Hi,
I was fucking dog. Yes, I'm here. Sorry.
Hello, Keld. Hello.
Hello.
All right. So what we're gonna do, A can be 5, 7, 9, or 13. So we're gonna try 5 first. So I'm gonna stick a 5 in there. B can be -11, -13, -15, -16. So I'm just gonna try -11. C can be 8, 10, 11, or 13. So I'm gonna put 8. Okay. So what we're going to do is we're just going to be organized about how we try these numbers. We're going to do one number at a time, just changing it through and then checking to see if the graphs match up. So we can tell right now that the first number in each column is not the answer. I can tell because the blue and the red do not line up perfectly. Yes, you can grab your charger. All right. So what I'm going to do is I'm just going to go ahead and change the C. I'm going to change the 8 out for a 10. Nope. Change the 10 out for an 11. Nope. Change the 11 out for a 13. Nope. So what I did is I checked the first number in A and the first number in B with all the numbers in C, and it didn't work. So now I'm going to move on to the second number in B. So in B, I'm going to do -13. And then I'll go back and try all the numbers in C again. 8. Ooh, look how close that is. Okay. 10. 11. 13. Oh, 13. Nope. Okay, so let's try the next number in B, which is 15, -15. And then we'll try all the numbers in C again. So 8. It's pretty close. 10, 11, 13. Okay, that didn't work. So now let's try 16, 8, 10, 11, 13. Okay, so we tried all of the numbers in B and all of the numbers in C with that first A value. That means that first A value cannot be it. Does that make sense? Okay, so I'm going to cross out the 5. That can't be it. I'm going to go ahead and try the 7 now. Okay, so I'm going to go back to the first B value. I'm going to try all the C's. 8, 10, 11, 13. Try the second B value. We have 13, 8. Oh, it kind of looks close. 10, 11, 13. Nope, 13. Look how close this one is. Negative 15 and 8. That looks really close. 10. Oh, is that it? Do we think this is it? Okay. Does anyone remember on the sub day the way that I double checked and I made for sure it was it? Not into the equation, because it is in the equation right now. I did something else. I did something that would help me check the decimals. Yeah, I clicked on the table. So I got this one right here. I got them both and I clicked on here and I said, show me the table. And then I clicked on here and I said, show me the table. And then I just compared to make sure the tables were the same, because the tables are how you're going to know. Okay, so they're getting, when they input the same number, they're getting the same output. And so those are correct. So for number 5, A is 7, B is negative 16, and C is 8. It's not the fastest way to do the problem, but if you do not remember how to add the two fractions together for a problem like this, it is a way you could do it. Okay, so that was the first page, 1 through 7. Any other questions on 1 through 7? Number 6, do we need to talk about how to do number 6? Yeah, so division, remember, makes you do keep, change, flip. And then if you have a negative exponent, it makes you take that piece and move it to the opposite side of the fraction. But you don't have to do this math by hand. You can graph the problem, graph the answers, and then see which ones line up. Anytime it says which expression is equivalent, you just have to graph the problem and graph the answers. That's how you can do any problem like that. So that's a good method. So when we look at the answer key, when I post the answer keys tonight, I will have all the math like by hand. You can see like every single step I did. But as far as how to do this in a calculator, so like to do things quick so that you don't have to remember all the math that we learned this year, anytime it says which expression is equivalent, you can graph the problem, graph the answers, and the ones that line up, that's the right answer. Does that make sense? Okay. Yeah. Do you want to look at, should we look at how to type that in on Desmos? Would that be helpful? Okay, so if we look at number 6, we have a fraction divided by a fraction. And so I'm going to type in a big division symbol first. And then we've got x squared minus 5x plus 6 to the negative 1 divided by something else. So I'm going to go ahead and start typing that. Yeah, we can do 11. Okay, so we got x squared, oops, x squared minus 5x plus 6, and then to the negative 1 divided by x minus 2 to the negative 2 divided by x minus 3 to the negative 1, x minus 2 to the negative, oops, put that on the bottom, x minus 2 to the negative 2. Okay, so I have the first fraction divided by the second fraction. Does that make sense? Okay, and then we just have to start typing our answer choices to see which one it is. So x minus 2 to the third over x minus 3 to the second. That is not it. That looks like a crazy graph though. Do you guys see that? Huh. Okay, x plus 2 to the third. And then x plus 3 to the second. Not that one, those both look crazy. Okay. And then 1 divided by x minus 3. Nope. And then 1 divided by x minus 2. Okay, let me make sure I have no typos. X squared minus 5x plus 6 to the negative 1. X minus 2 to the negative 2. X minus 3 to the negative 1. Minus 2, negative 2. Maybe let's make them show up one at a time. Oh, that's it. The colors were just so close, it was hard to tell. So it is D. Yep. It's right here, you just can't, the colors are so close. So I'm turning D on and off, and it's purple and black. So it's right on top of it, but it's really hard to tell. So let me, here, I'll go ahead and change my color so you can see it. Here. Okay, so now if I turn it on and off, you just have to be really careful when you type it. So here, here's the original problem right here, that's in black. So just be very careful when you type the original. And then there's answer D. Okay. Anyone on Zoom have any questions on that one? That one was number 6. Zoom people, we all good on number 6? Yes, so Zoom people. Okay, so the next set of questions we're talking about, we're checking for issues on 7 through 14. And I did have a request to look at number 11. So we're gonna do that one first. So number 11 says, which choice is equivalent to the expression below? And when you're typing in questions like this, if they have both variables, you have to put an equal sign in there. So if you do 48x to the third minus 243xy to the third, if you just type that, it's not gonna graph anything. So put equals 0, and then all of a sudden it will graph something. So that's the original equation we're starting with. And then to see which one's it's equivalent to, then you can just start typing your factors. So 3 times 4x squared minus 9y, 4x squared minus 9y, and then put equals 0, and then it will graph something. This one was y to the second. Oh, there we go. Okay, so that was the problem, 48x to the third minus 243xy to the second. Okay, and then here's this. There's the first one, I think with no typos. Okay, so it's not the first answer. 3, 4x squared minus 9y, 4x squared plus 9y. So it's not that one. 4x minus 9y, 4x minus 9y. So we'll just take away the squared. So it looks like it's that one. It's the third one. Oh, it's a plus. Sorry, it's not the third one. I forgot that I had a plus in there. It is D. You guys are right. This is the third one. It's that the third one is only half of it. And then if you put the fourth one, then you get the plus and the minus. So when you are doing choose an equivalent expression and you have two variables, you just have to put an equal sign in there to get Desmos to graph it. And then Desmos will show it. Okay. So of 8 through 14, is there another one? Yes. 14, yeah. So if you're graphing a piecewise function on Desmos, we'll do negative 3x, and then to do the limited domain, we do the squiggly bracket, and the squiggly bracket is shift, and then it's right next to P on your keyboard, shift P. So squiggly bracket, shift P, and then we'll do x is less than 2, and then 4x plus 1, shift P, X, and you're going to hit greater than sign, and then you're actually going to hit the equal button. Greater than equal. So once you hit the equal button, it will slip the equal sign underneath the greater than sign. Greater than or equal to 2. Okay, so there is our first function. How come? Where's the green? I'm not seeing the green. Oh, there it is. Okay, it's all the way up there. Okay. And then for g of x, we're gonna get x squared plus 2, squiggly bracket, x is less than 3, x to the third, squiggly bracket, x greater than equal to 3. And then here's the nice thing, for a problem like 14, you don't really need the graph, you just need the table because you're plugging numbers in. So if we go for each of these and say, hey, give me the table, hey, give me the table, hey, give me the table, give me the table, then you can use Desmos to plug in all these numbers for you. So it says h of 2. So if you look at this one, this is the one that's h of x. That's the first one. You can't plug in 2 to negative 3x. It's undefined. So don't plug it into the first piece because it's undefined. Plug it into the second piece. H of 2 is 9. So 3 times 9 is 18. So 3 times h of 2 is 18. I'll go ahead and write that on my paper. And then it says 4 times g of 1. So let's look at the second one. G of 1, we can look at both of these. Well, g of 1 on this one says, oh, g of 1 is 3. On the second one, g of 1 is undefined. So don't use the second piece, use the first piece. G of 1 is 3. So it says 4 times g of 1, so we're going to do 4 times 3 is 12. So did I type that right? Oh, 3 times 9, I wrote 2 times 9. 3 times 9 is 27. Whew. 27 plus 12 is 39. Yeah, so it's A, the answer is A. Yes. All right. We also had a request to do number 9. Number 9 is not one you can cheat on. This is one you actually have to know what you're doing because it's a rate of work problem, so it's not a calculator problem. So let me go ahead and get my document camera pulled up. So it says Martha can paint a room in 2 hours. And then it says, this is number 9. Let's see if it's gonna, document camera, are you working? Are you working, document camera? Why are you black? Document camera, document camera. Don't fail me. Maybe I can't show you what I'm writing. Hold on, let me open it again. So it says Martha can paint a room in 2 hours. Jamie can paint the same room in 6 hours. You guys remember what we write for stuff like that when it says that somebody can do something in 2 hours or something in 6 hours? You guys remember how we do that?
Yeah. Isn't
so,
it like, oh, I was gonna say, isn't it like you do like 1 over then like the number? Right? And then you like do that for each thing.
That's exactly right. So for Martha, we're going to put 1 over 2. And for, why is it showing black though? Well, I just turned it off. So for Martha, we're going to put 1 over 2. And for Jamie, we're going to put 1 over 6. So we're going to write, there we go. We're going to write 1 over 2 plus 1 over 6. Aha. And then, anyone remember what we do after that? Yeah, equals 1 over x. That's really good. All right, 1 over 2 plus 1 over 6 equals 1 over x. Hold on, I've got to get it so I can get bigger, zoom. Okay, hold on, big. And then share screen. And then there we go. That's bigger. There we go. Okay. So Martha is going to be 1 over 2. Jamie is 1 over 6. It equals 1 over x. And then if you guys remember this unit, we would figure out what the common denominator is. And then we would multiply the whole equation by that common denominator. So if we have a denominator of 2 and 6 and x, what's the whole common denominator? Bigger than 2, 6x. What were you going to say, Corey? Oh, at this point, yeah, no, you're right. You're right. At this point, we can cheat and use Desmos. Let's do that. So the part we couldn't cheat on was the coming up with the equation. The part we can cheat on now is solving the equation. So we can do 1 over 2 plus 1 over 6 equals 1 over x. Now Desmos, when you're using it just with numbers, if you want it to graph, you have to put equals y. And then it will actually graph it for you. So solving the equation 1 over 2 plus 1 over 6 equals 1 over x. The solution is right here on Desmos. And the x coordinate is the answer because x is what we were solving for. So how many hours does it take them to paint the room together? 1.5. So we're going to say x equals 1.5 hours. It takes them 1.5 hours to paint the room together. But what if this wasn't 1.5? What if that was 1 point? What if I don't want to zoom in like that? What if I don't, what if I don't like your sass, sir? All right. So this is the Jack method of typing the whole equation in, and then apparently just zooming. Zoom, zoom, zoom. Okay, so we got that one. Anybody else? Questions 8 through 14? We want to look at 12. Okay. So it says we have -1. Here we're going to look at this number. Okay, so -1 is a 0 with a multiplicity of 2. X equals 2 is a 0 with a multiplicity of 1. X equals 4 is a 0 with a multiplicity of 1. So just in case you guys forgot, multiplicities, this is a multiplicity of 1. It just goes, it's an x-intercept where it just goes straight through the x-axis. A multiplicity of 2 looks like this. I wrote m squared, but I didn't mean m squared. I meant just multiplicity of 2, but I wrote m squared. Multiplicity of 2 is where it, as it hits the x-intercept, it bounces. It looks like a mini parabola. And then a multiplicity of 3 is when, as it hits the x-intercept, it looks like a mini cubic at that point. So what they're saying is that these are the zeros of the graph, which is just another word for x-intercept. And it's saying that at the x-intercept of -1, it bounces. At the x-intercept of 2, it goes straight through. At the x-intercept of 4, it goes straight through. So all we have to do is just graph these answer choices and see what the x-intercepts are, and then if they're doing what we want them to do. So let's graph those answer choices. So we've got x to the 3rd minus 5x squared plus 2x plus 8. I'll zoom in so we can see it. So here's an x-intercept at -1, but it's going straight through. It's not a multiplicity of 2, so this is not the right answer. That's a multiplicity of 1. So we're going to ignore that answer. It's not A. X to the 3rd plus 5x squared plus 2x minus 8. Okay, this one, x-intercept at +1, multiplicity of 1. It's not that one. X to the 4th minus 4x to the 3rd minus 3x to the 2nd plus 10x plus 8. Okay, so here's that multiplicity of 2 they were talking about. Multiplicity of 2 at -1, multiplicity of 1 at 2, multiplicity of 1 at 4. Does that make sense? So that looks like the answer is C. Number 12 is C. How else would they phrase this problem so we know at this point? They might give you a picture and say to match the picture with the equation. And then you would say, oh, let me look at the x-intercepts and see what the x-intercepts look like. And then I would pick out the shape of the x-intercepts and say, oh, that x-intercept goes straight through, so it looks like this. Oh, that x-intercept bounces, so it's gonna look like this. And then I would use that to help me figure out. In fact, there were, I don't remember which review assignment it was, but that type of problem is on one of the 2 reviews. I did that on some of the answers. On an answer key somewhere, I did a problem like that. Okay, 8 through 14, any more problems we should look at? Okay, next page, 15 through 19. Any problems? 15 through 19. 16, we can do 16. Okay, so we have 2 things that we're looking at with 16. This is not really a good one for Desmos because we can't really cheat on this one. We kind of have to know what we're talking about. So we have to know what they mean when they say increasing and decreasing, and we have to know what they mean when they say positive and negative. So increasing and decreasing, we should be okay with. Zoom, zoom, no, nope, nope, nope. My document camera does not, I've broken it, does not zoom anymore. So what does it mean with increasing and decreasing? This is where I always put the stick figure. Where does it increase? Where does it decrease? Okay, so it increases first. And how far does it increase to? Yeah, like negative 2.5 about. Looks like it increases to like right there. And then what does it do? Decrease. And where does it decrease until? 0. It decreases until 0. Yeah, so remember we always use X values. So we don't care that the Y value is a -3. We only care that the X value is a 0. So I'm going to put a 0 right here. X value of 0 is where it's decreasing. X value of -2.5. Okay. A little side note on how they can phrase questions. If they ask you where something is happening, they want an X value. If they're asking what, like if they ask what the minimum is, what the maximum is, they're asking for a Y value. If they're asking what is positive, what the negative is, if just the what is the output, that's why it's a Y value, because Y values are the output of the function. So if they say what, that's what they're talking about. If they say where, they want a location, they want an X value. So the way these questions are phrased, when they say, like say where it is increasing or decreasing, all of these questions are asking for X values. Okay, so increasing to -2.5, decreasing to 0, and then what's happening over here? Increasing. Okay, so we have increasing, decreasing, increasing. And then how do we know if something is positive or negative? If it's above the x-axis. Yeah, so if the Y values are positive versus if the Y values are negative. So let me grab colors that are actually visible. So if the values are up here, the yellow is going to be the positive because we are above the x-axis. And then the blue values are going to be negative because we're below the x-axis. Okay, so now we just have to look at the x values that they're talking about and see if those x values are increasing or if they're decreasing or if they're positive or if they're negative, okay? So first they have the x value from -4 to -1. So they're talking about x values from -4 to -1. What do you notice about the x values between -4 to -1? Yeah, it's all yellow. It has increasing values and decreasing values. So it's definitely not either of those answers because it includes both of them. But it is completely yellow from -4 to -1. And that's what we colored as positive. So from -4 to -1, we're going to say that's positive. Okay, from -2 to 0, from -2 to 0, what do you guys notice? Decreasing, it's got yellow and blue, so it can't be positive or negative because it's got both of those. But it is all decreasing, it's all downhill. So it's all decreasing. So -2 to 0, -2 to 0 is all decreasing, okay? 0 to 2, 0 to 2. Okay, this one's interesting because it is just blue and it slants uphill. So it is both negative and increasing. It is 2 of the answers we have left. So we can't say which one it is yet because we don't know. Does that make sense? It is completely blue and it is completely uphill. You guys see that? 0 to 2, completely blue, completely uphill. So we're not sure yet. Okay, 0 to 4. What do you guys see about 0 to 4? It's blue and yellow, but it's completely increasing. So what should we put for this one? This one's increasing. Okay. 0 to 4 is increasing. So what does that mean about 0 to 2? Has to be negative. That was completely blue, so that has to be negative. Okay. How do you guys feel about 16? Anyone have any questions on 16? Okay. 17, 18, 19. What about 20 through 23? Yeah, I can do 18. Okay, so 18 says which function does not have all real numbers as its domain. So what are we comfortable with in the instructions? What are we uncomfortable with in the instructions? I know what domain is. What does domain mean? X's, right? It's talking about the X's, okay? So domain means like look left and right. Okay, when they say all real numbers, what would we normally write as our answer for domain if all real numbers was the answer? Yeah, so what we want to do is we want to graph the answers and we want to see which ones go left and right forever. That's what we want to, we just want to look and see which ones go left and right forever. And you guys have done this. Every unit you've looked at these and seen which ones go left and right forever. So if we graph them, we should be able to recognize it. So 5 to the x minus 3. Okay. Left and right forever? Yeah, okay. So it's not A. B. X plus 1, x plus 3. Left and right forever? Do you remember what this unit was called? Is it continuous or not continuous? Yeah, because what is continuous? What has to happen with continuous? Yeah, you're not supposed to pick up your finger. Okay, so we feel iffy about this one, right? So we think the answer might be B. Let's try C. So for C, 2x minus 1. Can everyone type this on Desmos? Okay, so this one, does it go left and right forever? Yeah, okay. And then let's try the last one, cos x plus 1. Oh, left and right forever? Yeah, okay, so B is the only one that we were like kind of iffy about. And then when we graphed the rest of them, what's our conclusion? It was B, yeah. And the reason it was B is because B has a vertical asymptote. Right here, I'll show you. At x equals -3, that black line is a vertical asymptote. It's an imaginary line that is not crossed in this particular case. So what Emma had noticed is that when you trace it with your finger, you pick up your finger and that value of -3 just never gets touched. So this graph is not continuous. It does not include the value -3. And if you guys were gonna write this on our paper, because maybe it'll show up, we don't know. But if you were to write this domain for B, the domain of this problem, if you guys remember, was -infinity to -3, -3 to infinity. If you guys remember that, that's what the domain was for those rational functions. Okay, yeah. Yeah, okay. So 20 is a unit circle question. It is saying the x coordinate, and they're kind of giving it to you. So you don't have to have the you don't have to have the unit circle memorized to do this question. You just have to kind of remember a few things about it. So if you guys remember, the x coordinate corresponds to which trig function? Cos. So if the x coordinate is -1/2, we would say cos theta equals -1/2. Now they want us to find the measure of theta. So how do we solve for theta? We do cos inverse. Cos inverse, cos inverse. So theta equals cos inverse of -1/2. Now we have to type it in our calculator, which means we are about to hit the cos button. And if we hit the cos button, we have to make sure that we are in the correct mode. So we are either in degrees or we are in radians. And you can always tell from the context of the question. So based on the context of this question, what should your calculator be in? Your calculator should be in radians because they said to the nearest thousandth of a radian. So you're going to type second cos -1/2. Cos inverse second cos -1/2. You're going to make sure your calculator is in radians. Oh, it's because it's the second answer. They're evil. Yeah, no, you're good. Yeah, that works. They were mean and they did the answer. They're being jerks is what they're being. Okay, so if you did, hold on, I have to think about this for a second. Yeah, okay, so if you were to do cos of -1/2, it would give you this number right here. I hate them because I didn't teach you this. Yeah, I'm trying to, so if you have the unit, so the reason I didn't catch it is because I have the unit circle memorized. So I just did it off my memory and I didn't catch it. You guys don't have it memorized. So I'm trying to think how you would do this problem if you didn't have it memorized. So this problem, okay, well, here's maybe what you guys could do. So what Madison was saying that she did is she was remembering that this number down here, correct me if I'm wrong, Madison, is that if this number down here is 270 degrees, she's remembering that if this is -1/2 for the x coordinate, that this would be 240 degrees. That's what you're thinking? Yeah. And so then she was thinking, okay, if that's 240 degrees, let me take it and convert it into radians. So times pi over 180. And so if you do 240, and since they want the decimal answer, not the actual radian answer, you can just type this in, 2 times pi over 180. You don't even have to simplify. You can literally type it in like that and you'll get the answer. You literally type the pi in because they want the whole decimal. What I did when I did this problem is I looked at that and I said, oh, that's 4 pi thirds because I have the unit circle memorized. And I was like, oh, that's where 4 pi thirds is. So I didn't even think it through how you would do this, how it would be more difficult if you didn't know the unit circle. Yeah, cosine and tan have their own little tricks and you learn the tricks in pre-calc, which is, yeah, unfortunate. Okay, does everyone understand? So go ahead and scribble this out. This didn't work. This would only work if the answer was on quadrant 1 or 2. I wasn't thinking about that. I have not sent out the tutorial yet that you guys have to watch. I will send out the tutorial tonight that you guys have to watch before you take the EOC. Thank you for the reminder. Okay. I also had a request for number 22, so let's look at that one. Okay, So this one says that you have the vertices of a triangle that are at 0, 0, 6, 6, and 9, 3. So let's go ahead and graph those on Desmos so that we can see what that looks like. This problem I thought was a lot harder until I graphed it. And then I realized something. This is problem 22. So if you look at these, if you graph the line y equals x, this is what they're rotating it around, is the line y equals x. And then this right here, if you guys can see that the line y equals x, this is a slope of up 1 over 1. And you can see this one right here is down 1 over 1, down 1 over 1, down 1 over 1, which means that this line right here and this line right here would be perpendicular to each other. They make a 90-degree angle. So the triangle that's formed between those 3 points is actually, if it rotates, it's actually going to make a cone. So this problem is not near as hard as you would think it is. Let me go ahead and draw a little sketch on my paper, maybe so you can see it a little bit better. So if we have 0, 0, 6, 6, and then 9, 3, this right here is on the line y equals x. That's what they're rotating it around. And then this right here actually makes a 90-degree angle. And the reason that you can tell that is because the two slopes are negative reciprocals of each other. So this slope goes up 1, right 1. This slope goes down 1, right 1. Does that make sense? Okay. So then what we need to know is if they're rotating it around this, we need to know what this length is, because this length is the radius of what's going to make the cone shape. So if you can imagine, we're going to have this, and as you rotate it, it's going to rotate this way. And then there's your cone. Does everyone see the cone? So there's your radius, and then this side right here is your height. Okay. Does anyone remember the distance formula, the distance between 2 points? Distance formula. You did not learn it in this class. You learned it not even last year. I know in Math 2, when I taught Math 2, we did go over it in Math 2. We reviewed it, but the students actually learned it before Math 2. Distance formula, distance between 2 points, anybody? It kind of would remind you of the Pythagorean theorem a little bit. It's got a big square root sign in it. Yeah. Yeah. There's no divide. It's just x2 minus x1 squared plus y2 minus y1 squared. So you just take, if you have 2 different points, you take the x coordinates and you find the distance between them and you square it. You take the y coordinates and you find the distance between them and you square it, and then you square root the whole thing. So it's similar to the Pythagorean theorem. So I'm going to find the distance between 0, 0 and 6, 6. And I'm going to find the distance between 6, 6 and 9, 3. So the height is going to be 0 minus 6 squared plus 0 minus 6 squared. So 0 minus 6, 0 minus 6. And then the radius is going to be 6 minus 9 squared plus 6 minus 3 squared. Now, when you take the EOC, you can get a lot of points just with the algebra problems by manipulating a calculator. The geometry problems, you kind of have to remember what we learned, okay? It is okay if you don't get every single geometry problem right, okay? It's not a big deal if you don't get all of them right, because you'll be able to get so many points from the algebra problems. Does that make sense? So don't sweat it if you run into one like this and you don't get it right. It's not a huge deal, okay? All right, so I'm not gonna type in the big square root. I'm only gonna type in what's underneath the square root because this problem has the square roots in it. So I got 0 minus 6 squared plus 0 minus 6 squared. Okay, so this one is square root 72. And then 6 minus 9 squared plus 6 minus 3 squared. Okay. Okay. So how do we find the volume of a cone? Yeah, we do the area of the base. We'll go ahead and do that first. So pi times the radius squared, which is just 18 pi. And then the volume, I should tell you, I got this problem wrong the first time I did it because I forgot the 1/3. And then the volume is 1/3 times the area of the base times the height. And we have a calculator. We don't need to simplify the radical like they did. We can just get the decimal answer and call it good. So I'm going to go ahead and type all of this in my calculator and see what I get. And then I will compare this decimal with the decimals that they got. So there's my answer. And then we can just type in, now I'm not even going to type in the first two because they didn't even have a pi in the first two. I'm going to type in the second two. 36 pi root 2, 108 pi root 2 is the first one. So C. Answer is C. Okay. So that one was a difficult one. And if you run into one like that and you have to skip it, it's not a huge deal. I would not beat yourself up. Okay, someone asked if we could do 21. So let's go back to 21. So this is another problem that we could do sliders with. So let's go ahead and get them set up in the problem. So we've got a sine bx plus h. Put sliders on all of them. Yeah. Mm-hmm. Yeah, totally. Yeah. So there was one thing that I found that was really easy to solve for first, in my opinion. And that was the first clue, a period of 6. Do you guys remember how you find the period of a trig function? It's 2 pi divided by, yeah, it's 2 pi divided by the number in front of x, which in this case is that b value. So 2 pi divided by b is 6. And so I went ahead and found b because that was going to be, it was going to make our lives easier if we did that. So then I just said, okay, let's go ahead and multiply the b over. And we get 2 pi equals 6b, and divide by 6. And so b equals pi thirds. So I already knew that this answer had to be pi thirds. And then now with the other one, so you can kind of treat this like the sliders, like the other one we did. But I think this one is a little bit easier because you have some clues that are going to make your life. So remember to do pi, we do pi divided by 3. Okay, so that part's done. I'm going to go ahead and change this to be, my step to be pi. So if you want the x-axis to be in terms of pi, you just have to go over here and put your step in terms of pi, pi. So there's that. I feel a little bit better about that. Okay, so since we have some clues on here, like it has a minimum value of 2, that means that the lowest the graph goes is 2. Then I think that because of that, we can, like, I don't know, do some, when we play with the numbers, like we can maybe make our lives a little bit easier. Just kind of look for one that does that. So this one has a minimum value of 0, so that's not going to work. Oh, the other thing we have is that if you plug in 2.5 for x, you get 5 for y. So let's go ahead, hold on. Let's make that point show up on the graph. So 2.5 for x, get 5 for y. So if you put that point here, then we can just make it so it shows up on the graph. Does that make sense? Okay. So we can go back and try it with the first one. So there's the point with the first set of problems with it not going on the graph. So 2 pi thirds and 2 definitely is not the right answer. Plug in 4 for the h. And then it looks like you kind of luck out and that ends up being the right answer. 2 pi thirds and 4. Easier than the other slider problem. Okay. Um, 24 through 29. Any questions? Yes. Yeah. So let's look at 25. Okay. So for this one, now they have these markings in the each vertice, and what do those markings tell you about the triangle? Each of the little angles are equal. So if these two angles are equal, then what does that mean about these lines that are cutting into the angles? Not that the lines are equal. What are the lines called though? What are lines called if they cut into angles and make them equal? The angles are equal. And the lines that cut into the angles are called, yeah, angle bisectors. So point G must be what triangle center of concurrency? Anyone remember? Yeah, it's the incenter. It's the incenter. So if these are angles that are bisected, then that means that G is an incenter. Okay. If G is an incenter, that means that there's a circle that we can draw. Anyone remember what type of circle we have that we can draw? There's two types of circles that you can draw with the triangles. There are circumscribed circles or inscribed circles. They either go on the outside of the triangle or the inside of the triangle. You guys remember which one it is? Inscribed. So we're going to draw the inscribed. So that's what those extra markings were for, from G to H and G to J and G to K. They were drawing the radius of the circle from the center, from that triangle point of concurrency that's in center to the edge of the triangle is the radius of that inscribed circle. And they're all equal in measurement. So G to H is x plus 3. P to G is 4x plus 1. And then G to J is 2x minus 1. Okay, so the two sides that we're going to work with are going to be G to J and G to H, because these two sides are both radiuses of the circle, so they have to be equal in measure. Does that make sense? So we're not going to use this one. This one is a different length, but these two are the same length because they go from the incenter to the outer edge of that inscribed circle. And all of that we could see because we saw the bisected angles and we knew that this was an incenter. Okay, so we're going to do x plus 3 equals 2x minus 1. We're going to solve that equation. And then once we've solved that equation, are we done? Is that it? You have to plug it back into PG because they want the measure of PG. So we're going to take it, plug it back in here. So what's the measure of PG? 17. Yeah. Okay. So 27 talks about an isosceles trapezoid. And this question I don't love because in the scheme of things, we don't spend much time on isosceles trapezoids, if any. I don't know. I think trapezoids were maybe on one assignment, but I don't think we ever found the area of them. Yeah, so the formula is, so this is what we call the height, which is not given to you in the problem. And then this is, you call this one of the bases, you call this the other base. And the area is 1/2 times the height times one base plus the other base. That's the formula for area of a trapezoid, isosceles trapezoid specifically. Mm-hmm. Yeah. So this base is 16. This is going to be the shorter one. This would be 26. They tell you that the sides are 13, which does not is not going to be part of the area formula because it's not the height, it's the slanted side. So we're not going to use it. It's not the height. So what we need to do is we got to break this picture down. So if you can see this, what we did is we made a right triangle right here. So here's your right angle. So if this is 16 and this is 16, then 26 take away 16 is 10, right? So that means that this whole length would be 16 on the inside, and this would be 5, and this would be 5. Does that make sense? So we have a right triangle. I'll draw it bigger so we can see it a little bit bigger. So we have 13, 5, and then we have the height of the trapezoid. So I took this triangle and I just drew it bigger right here. Yeah, you're good. So if this is our right triangle, we need to find the height. We're going to do 5 squared plus h squared equals 13 squared. And then what would the h be? Perfect. So the height of the trapezoid is 12. So at that point, you can plug all your numbers in. So you got 1/2, height of 12, and then your 2 bases. So there's your trapezoid. And then it says, the new material is 2.5 square feet. You can cut it in whatever shape you need it to be cut. Crazy unrealistic, but fine, I'll buy it. So they're gonna say, take this and then divide it by 2.5 to see how many pieces you need. So one piece is 2.5. So take the entire area, divide it by 2.5. And so we would need 100.8 pieces. We're gonna round that up. So the answer is, hey, we need 101 pieces. That's right, that problem was dumb. I agree. Okay. 26. If you have a question like 26 and you have to do the length of the radius, I would graph the problem on Desmos. And then, so let me go ahead and put this back into not pies. So I'm gonna put my steps back into ones. Ooh, maybe not ones. What was a pi before? It's a lot of lines, that's annoying. Fives, there we go. I would graph this on Desmos and then count the boxes. So x squared plus y squared minus 4x minus 4y plus 4 equals 0. So if the center is right here, that center's at 2, 2. Then it goes over 2, so the radius is 2. So you can do, that's a geometry question that you can do really easy on Desmos. It's just graph the circle and count the boxes. So as long as you can find the center and then count from the center to the edge, you are good. So for number 26, the length of the radius is 2 units. Just find the center and then count from the center to the edge. Okay. Anything else? Okay. So that was a lot in the first review. I'm not going to keep you more than an hour and a half. Let me make sure I wrote down everybody's names. If you have some questions, hold on, don't leave yet. If you have some questions that you would like to ask, you are welcome to stay longer. Certainly, and ask questions. But if you feel like you are good, you've got the problems done, you're ready to just submit your answers and go, I'm fine with that. And you are welcome to leave. Hold on, just want to make sure I got everyone marked down. I think I do. Okay, so you guys are welcome to go if you want. And then if you have some questions on the second mixed review that you would like to ask, then you are welcome to stay behind to ask those questions. Thanks for coming, and I'll send out the tutorial later today. Due at 5. It's due at 5. No, the answers have to be submitted by 5.